Whether you're pondering alternate timelines that split into infinite possibilities, a completely different set of fundamental particles, or a reality where you came up with that hilarious comeback just in time, you have to admit that the idea of parallel universes is pretty exciting. And with modern advances in cosmology and particle physics, we're refining our ideas of what exactly our own universe is made of, how it got started, and whether there might just be another one or two or infinitely many more out there. Or right in here? So how close are we to finding a parallel universe? When we consider what might lie beyond our observable universe, a few pretty cool theories emerge. Many are not directly testable just yet. After all, if we could observe it, it would become a part of our observable universe, right? But as it turns out, we have plenty of places to look in the game of hide and seek for other universes. So let's start with our most basic vanilla theory and work our way up to the more ghost pepper, ice cream with rainbow sprinkles type ideas. There's a type 1 multiverse, a quantum multiverse, a mirror universe, bubble universes, and baby universes inside black holes. The first proposal is what physicist Max Tegmark coined the type 1 multiverse, or what I like to call more of the same.
One version is just to say that we can observe some finite region of the universe, but there's probably more out there. So that sort of multiverse almost certainly exists. It just says that the universe is much bigger than the universe that we can see, but that's not that much of a surprise.
Okay, but if our own universe is defined by what we can observe, what if it's those observations themselves that spawn more universes? What if every time you chose an ice cream flavor, for example, 30 other universes branched off where all other possible outcomes came to fruition? This is the next possibility, what you might call the quantum multiverse, where things get a little more interesting.
The multiverse, where whenever something in the quantum world happens, the universe kind of splits into two copies. This is the so-called many-world version of quantum mechanics. You know, in quantum mechanics, you can have version A of something and version B, and usually that's something like an electron. But, you know, it doesn't weird us out that much that there's two versions of an electron. There are experiments that are now making two superposed, that is kind of added up versions of complex molecules. There are people who are even trying like the simplest viruses. And so as technology gets better, we might find that there's a limit to how big of an object we can make two versions of, or there might not be. And at some point, we might have two versions of a person.
But don't get too excited to meet your new evil twin or Spock with a goatee anytime soon. Quantum phenomena are famously tough to understand and manipulate because, by definition, observing them collapses their coexisting realities into just one, our own. But what if we could observe quantum effects on other particles? Could there be clues about another universe lurking right under our nose? And that brings us to the third idea, mirror matter.
Mirror matter was originally hypothesized because of a discomfort with the fact that the weak force, one of the four fundamental forces in the universe, actually prefers to couple to left-handed particles. We realized that in order for this to be a valid theory, it probably shouldn't interact very strongly with our own universe. Mirror matter was actually one of the first and oldest possible candidates for dark matter.
That's what Leah and her colleagues at the Oak Ridge National Laboratory are busy hunting for, using one particularly pertinent particle, the neutron.
What's really interesting about the neutron is because it is electrically neutral, it can undergo a process called oscillation. This is a quantum mechanical phenomenon in which a particle can just move back and forth from one state to another. So if there were some mirror partner to the neutron, some dark neutral twin, then the neutron in principle could undergo an oscillation into that particle. And if so, that's something we can detect.
Beyond this wall is a large liquid mercury target. And through a process called spallation, it shakes free a bunch of neutrons from this very heavy mercury nucleus. Once the neutrons are cooled down, they travel down these beam guides into the sample area of the instrument. We use a wall made of a really thick boron carbide to absorb any neutrons that try to pass through. If a neutron can oscillate into a mirror neutron, it'll pass through the wall. And then on the other side of this wall, those mirror neutrons then have a chance to oscillate back into regular neutrons.
If we're able to confirm that what we see really acts like a mirror neutron, that would be very strong evidence that something like mirror matter, this mirror universe, must exist.
While Leah and her team continue to search for that elusive mirror universe, this theory is still up in the air. But she can tell you one thing for sure.
I definitely don't have a pet Demogorgon.
While mirror matter would be one alternate reality right here in this room, what if the answer to the multiverse lay way out in what's known as the cosmic microwave background? There, at the edge of everything, lie clues about the beginning of our own cosmos. And it might not be as straightforward as it seems.
You can think of the Big Bang as that kind of fireball that was the hot plasma that was expanding. But you can also think of the Big Bang as like the beginning of everything, the beginning of time and space and so on. And those two things, it turns out, are not exactly the same. Could there be a whole era of cosmic history in between the beginning of the universe as a whole and that fireball that led to our observable universe?
This is known as inflation. And in the version where it goes on forever, eternal inflation. Inflation is the idea that something as small as a kilogram of material can be blown up to become the entire observable universe and more.
This inflation process, it turns out, is very, very, very effective. So it doesn't just create the observable universe, or even a million times bigger, but it generally keeps going, creates huge amounts of space and time, including possibly regions of space-time with very different properties than the one that we inhabit. There are these other big regions that we might call universes, but they might have very different properties, different laws of physics, different constants that might have beings in them and so on, that might even have a different number of dimensions, all brought about by a single process.
And there are a few ideas about what exactly that process entails. One flavor suggests that the multiverse might look something like a root beer float, where our universe is just one in a series of bubbles.
It's a little bit too far away. Now imagine that there's some sphere that smashes into this, right? It'll bruise, it'll dent one side of this. And that's exactly what a collision with another bubble would do. It would create a sort of disk on the sky that was a little bit different than every other direction. My collaborators and I have actually done this, taken the microwave background data, looked for these signatures, looked for patches on the sky. We found some. That's the exciting thing. The unexciting thing is that the things that we found are totally explainable as just random variations in the regular microwave background.
With more and better data on the edge of the universe, we could study features like temperature and light polarization of the CMB in more detail to do more sensitive tests for this kind of impact. And in the realm of inflation exists another out-of-this-world theory, and this one might just be the cherry on top.
A fairly natural process just in the dynamics of inflation before our sort of hot fireball Big Bang could have created a whole bunch of baby universes. They would appear to us as black holes, but inside each black hole would be a sort of wormhole that connects to a baby universe.
So, if all we need to do is figure out how to jump into a lucky black hole, find a bruise in the farthest stars, confirm some neutrons are where they shouldn't be, or build a quantum copy machine to pin down quantum dynamics for good, how close are we to finding a parallel universe?
Very close. It's right here. For the quantum multiverse, it's here all the time. We just have to believe it. For a mirror sector, it's right here. We just have to detect it. For a baby universe inside a black hole, we have to go and find it.
Over the next 5 years, we're going to be exploring a lot more possible mechanisms by which the neutron can oscillate into mirror neutrons. And as even better, brighter sources of neutrons appear around the world, on the 10-year timescale, we think that we can really probe a lot of interesting space where parallel universes might be hiding.
If we're looking for a bubble that's running into our bubble universe, those really could appear in the data at any time with lots of luck, but that's something that even in 5 or 10 years, more data will certainly exist, and that's data that we can check for that effect. So somewhere between right now and thousands of years, I think we'll definitely maybe find one.
To discover something like that would revolutionize physics. I don't even know what would come next, but it would be very, very exciting.